Hassler here. I'm going to take you through lesson 7.3. So in the previous lesson, we had worked through the graph of the parent function, y equals x squared. It is the parent function for quadratics. It is the most basic function. And so today what we're going to do is we're going to look at what happens when we start adding or subtracting numbers to and from that parent function of f of x equals x squared. All right, so problem 1 says complete the table of values for f of x equals x squared and g of x equals x squared plus 3, and then describe what you notice. All right, so f of x is x squared. I'm going to write that here so that I can, associate f of x with x squared. And recall what that means is that I'm going to be squaring the -4, that's my x value. To square a number means I multiply it by itself, so -4 times -4 is going to be a positive 16. -3 squared is going to be a positive 9. Then I have a positive 4, a positive 1, a 0. 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Okay, so that is the parent function, x values, matched with the f of x, y values. But now it says to evaluate or complete the table for the g function, and the g function is this x squared plus 3 function. Well, what I notice is that I have the parent function x squared, and then I have plus 3 at the end. So let's think about this. If I substitute -4 in, I'm going to have -4 squared. I know that's 16. And then I'm going to add 3. So 16 plus 3 is 19. In fact, I would do the same thing for -3, right? If I put -3 in for x, I get -3 squared, 9, plus 3 is 12. And what I notice is I'm just taking these outputs from the parent function, and I just end up adding 3 to each of those. So 4 plus 3 is 7, and 1 plus 3 is 4, and 0 plus 3 is 3. So I get 4, 7, 12, and 19. Okay, so it says describe what you notice. Well, I notice that all the y values for my g function are 3 more than the y values for the f function. I also notice that my vertex for the parent function is 0, 0, and the vertex for my g function is 0, 3. Notice how I'm skipping that middle column. I know that 0, 3 is the vertex for my g function because I start to get these repeating y values on either side of that value of 3, that y value of 3. The vertex is the only y coordinate that does not repeat in this pattern for quadratic functions. Okay, so problem 2 says graph both the f and g function on the graph below. I'm going to go ahead and use the colors that I created my table with. So the f function I'm going to graph in red. I have -4, 16, and I have -3, 9. And be careful because this y-axis does go by 2s. I have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and 4, 16. I'm going to connect those with a nice smooth curve. And I'm going to toss some arrows on the end. I really could have kept going upwards on either side of this y-axis. And I'm going to label this the f of x graph, if you can't tell already by my colors. All right. I'm going to go ahead and graph the blue graph, the g function. And so I have -4, 19, so -4, 19. And I have -3, 12. I have -2, 7. I have -1, 4, and I have 0, 3, so 1, 4. And remember, I get this symmetry on either side, so notice that at 3, I'm going to have the same output as I do at -3, and at 4, I'll have the same output that I did at -4, and I'm going to connect that. I'll label this the g function. And it says, describe how the graphs of f and g compare. Well, to me, it looks like the g function has been shifted up 3 units from the f function. That seems reasonable because I added 3 to the original parent function. Okay, so it looks like g is shifted up 3 units from f. And again, that seems reasonable. Shifted up 3, I have this plus 3. All right, let's go ahead and answer some more questions about this graph that we have. So it says, what is the vertex of G? So the vertex of G is that turning point, that lowest point. We said in the table it's that 0, 3. What is the axis of symmetry for G? So remember, the axis of symmetry is this imaginary vertical line that's going to cut right through that vertex, go right through the middle of our graph. It is a vertical line, and so we write it as an equation. All of the x values for this equation is 0. If I were to plot every point on this imaginary vertical line, they would all start with 0, comma, some y value. Or you can think about it as I'm going through the x-axis at 0, and so x is equal to 0. We said that the domain for these quadratic functions is always all real numbers. But we also said that we could use a symbol to abbreviate all real numbers, and that symbol is that R with that double stem. And then it says to identify the range of G, and a range, remember, are all of the y values that get used. And so when I look at my graph here, I notice that all my y values that get used are positive y values, and they're all bigger than 3. Right, 3 is actually the lowest y value that I have. So 3 gets used, and then every y value bigger than 3 gets used. And so we can say all y values greater than or equal to 3 get used. Okay, so I'm going to move on to the next problem. It says predict what you think would happen if the graph, if we graphed the function h of x equals x squared minus 3. Check your prediction using Desmos and graph h of x on the grid above. Okay, so if x squared plus 3 was an up, so x squared plus 3, this plus 3 shifted us up 3, I'm going to predict that the x squared minus 3, that minus 3 is going to shift us down 3. That would be my prediction. So we're going to jump over here to Desmos, and you can see my red graph here is actually the parent function. Over here in red, it says y equals x squared. And if I graph y equals x squared minus 3, oh, yes, okay, so my blue function pops up, and it does look like I've taken my vertex and I've shifted it down by 3 units. So I can see here that my vertex has been shifted down by 3 units. In fact, this point at 1, 1 has been shifted down 3 units. And so my guess was a reasonable guess. All right. And so what is the vertex of h? Well, actually, first, let's graph this. Let's graph this function. And so based on my graph from Desmos, we said that I now have a vertex at -3. And in fact, every point from the parent function gets shifted down 3. So I was at 1, 1. So if I go down 3, I'm going to be at 1, -2. Symmetry shows I'm going to be at -1, -2. The parent function has a point at 2, 4. So if I go down 3, I'm at 2, 1. Symmetry says I'd be at -2, 1. I'm at 3, 9. If I go down 3, I'm going to be at 3, 6. Symmetry shows that I would have -3, 6. And so that's plenty of points. And let's connect those. So we'll call this the h function. And so now I can answer some questions about this h function. It says, what is the vertex? Well, now I have a vertex of 0, -3. And what's the axis of symmetry? Well, it's the same. I'm still cutting through the vertex when x is 0. X equals 0. And what's the domain? Well, it's always all real numbers for all quadratics. And the range, well, this time my lowest y value is at -3. And so all the y values that are bigger than or equal to -3 would be my range. Okay, so these types of questions, vertex, axis of symmetry, domain, and range, these are going to be asked on repeat. All right, so let's move on to the next page. And let's take a look at what's happening if I'm graphing a slightly different version of the parent function. All right, so at the top of this page, it says graph the parent function on the grid to the right. So we're going to go back and graph that parent function. I think I had it in red before. Remember that parent function is y equals x squared. So we've got 0, 0. We've got 1, 1, -1, 1. We have 2, 4, and -2, 4. We've got 3, 9, and -3, 9. And we have 4, 16, and -4, 16. Okay, so there's my parent function. All right, 5 says graph j of x equals the group. So notice I have parentheses this time of x minus 4 squared using Desmos. And then we're going to sketch it on the grid to the right and we're going to label it. So let's go ahead and do that. Come over here. I'm going to turn that one off. And we have y equals parentheses x minus 4 and then squared. And I notice that for this particular graph, I've not been shifted up or down. I've shifted to the right. And so compared to my parent function, I have actually been shifted to the right 4. So here's my vertex, 1, 2, 3, 4. So it's interesting because this minus 4 kind of made me think I was going to move to the left 4 since left is a negative direction, but I'm actually doing the opposite and I'm going to move to the right 4. It turns out that every point on the original parent function, 1, 2, 3, 4, gets shifted 4 units. So at negative 2, 4, if I go 1, 2, 3, 4, I'm now at the new point for my new function that got typed in. And so we're going to go ahead and graph this. It says, how does this graph compare to the parent function? We shifted right 4. And so every single point on this parent function is going to get shifted right 4. The vertex gets shifted right 4. 1, 1 gets shifted right 4. I have the symmetry. 2, 4 gets shifted right 4. I have the symmetry. 3, 9 gets shifted right 4. I have the symmetry. Well, that's good enough. All right, so I'm going to label this. This is the j function. Now I'm going to answer some questions. The vertex of j is that lowest point, that turning point. We have 4, 0. The axis of symmetry, so this is going to be a little bit different. The axis of symmetry, since the vertex moved, so did the axis of symmetry. The axis of symmetry is now this vertical line. It goes through the x-axis at 4. So notice that that axis of symmetry is matching my x-coordinate of my vertex. The domain is always all real numbers. And my range, well, the lowest y value, if I have 4, 0, the lowest y value is 0, so all the y values bigger than or equal to 0 would be my range. So problem 6 says, let's think about the function k of x equals x plus 3 squared. Without using Desmos, how do you think the graph of the function will compare to the parent function? All right, so let's see. If minus 4 in parentheses moved me right 4, I'm going to guess that plus 3 in parentheses is going to move me left 3. Okay, so we're going to use Desmos to check this. Okay, so let's go over to our Desmos screen, and I'm actually going to we'll leave that on. And we are going to do y equals parentheses x plus 3 squared. And there it is. My purple graph has been shifted to the left 3, even though the plus inside the parentheses makes me believe I'd move to the right since that's a positive direction. I'm actually doing the opposite. So when I'm inside parentheses, I'm doing the opposite of what I thought I would be doing. And when I'm outside of the parentheses, I'm moving up or down exactly the way I thought I should be moving. Oh, math. All right. So I was right. I'm going to go ahead and graph this. So I'm going to take this vertex. I'm going to shift it this time to the left 3. So I'm at negative 3, 0. And I'm going to take this 0.11. I'm going to shift that left 3. Use my symmetry. I'm going to take the 0.24. I'm going to shift that left 3. Use my symmetry. And that's pretty good. Okay. And we're going to label this. This was the k function. Okay. And so now I have a vertex at negative 3, 0. Which means that, again, my axis of symmetry has moved compared to the parent function. My axis of symmetry is going to go right through that vertex. I'm crossing the x-axis at negative 3. Again, notice that that matches the x-coordinate of the vertex. The domain is always all real numbers. And the range, well, the lowest y value I have is 0, and all the y values are bigger than or equal to that. So y is greater than or equal to 0. And so let's put this together. 7 says, consider the function p of x equals x minus 4 squared plus 3. Answer the following without graphing on Desmos. And so let's see. Let's think about this. We said that when we're on the outside, that plus 3 on the outside means I'm going to move up 3. And when I'm at minus 4 on the inside, that minus 4 actually means I'm going to do the opposite. I'm going to move right 4. And so if I take my vertex of the parent function, which is 0, 0, and I shift that to the right 4, I'm going to be at negative 4, and up 3, I'm going to be at 3. That's where I think my vertex would be. So even though it says to answer the following without graphing on Desmos, I just want to go ahead and check this vertex, make sure I'm right. And then I should be able to identify everything else based off of that vertex. Okay. I'm going to shut these two off. And I still have my parent function there. So we've got y equals, and then I have x minus 4 squared, and then I have plus 3, and there's my graph. And oh no, I did make a mistake, didn't I? I said I'm going to go right 4, but if I go to the right 4, this should be a positive 4. See what happened there? So it's not going to be the sign that's given inside those parentheses. Good thing I checked. So we have to be careful. If I'm moving right 4, I'm going to be at a positive 4. And I'm moving up 3, I'm going to be a positive 3. So it's always good to check on Desmos to make sure that you are having the correct answer. All right. From here, I should be able to answer the rest of the questions. The next question is, what's the axis of symmetry? So I'm going to go through my vertex, which has an x value of 4. So x equals 4. The domain is always all real numbers. And my range, well, my lowest y value is 3. So my range is going to be all y values greater than or equal to 3. Okay. So I'm going to come back here and fill that part in. So the axis of symmetry is x equals 3. The domain is always all real numbers. And the range were all y values greater than or equal to. I am sorry. X equals 4 was our axis of symmetry. My apologies. X equals 4 because that's the x coordinate, and the range is y is greater than or equal to 3. All right, so just to verify, axis of symmetry, we have, we're going through the x-axis at 4, x equals 4. Okay. So your job is to go and watch the next video, because in the next video, we're going to talk about a few more transformations that we can do with this parent function. And then after that, we can put it all together and work on the 7.3 practice. If you have any questions, let me know.